Hi everybody. Well, this is the last section of chapter 7, and we're going to sort of take all the stuff we've done in the last two sections and show how that leads us to something called the quadratic formula. This is so with this formula we can solve any quadratic equation. That is, find those roots or the solutions to a quadratic equation. And you're thinking, well, what's wrong with the things that we used before, like completing the square? Well, this is essentially completing the square with where we're bypassing the actual completion and we're plugging in some numbers. So let me just show. I want to show you how we develop this first. You're not going to be required to know how to do this stuff, but I just want to show you where this comes from. So again, a quadratic equation is an equation like this, or equation that can be put in this form, where if a, b, c are real numbers and a is not 0, then ax squared plus bx plus c equals 0. That's a quadratic equation. And because a is not 0, we can divide both sides by a, and we get this. And we can subtract c over a from both sides, and that gives us this equation. And the reason why we want to do this is because we have something in the form of x squared plus a number times x, and that's where we can complete the square. So we take the coefficient of the x term, divide it by 2, and square it, and that's what we add to both sides. Okay, well, what that is in this case, if we take b over a and divide by 2, that's the same thing as multiplying it by 1/2. So b over a times 1/2 is the same as b over 2a. So we square that, we add that to both sides, and as a result, these three terms can be combined into this expression, x plus b over 2a squared. And then this, we can do some getting a common denominator. This of course would be b squared over 4a squared. And then we can take this and multiply this by, we want a 4a squared to be our denominator, so we multiply and divide this by 4a. And so then switching this around, this is b squared minus 4ac all over 4a squared. And now we can take the square root of both sides, and then this is just b over 2a. We subtract b over 2a from both sides. And actually, we first use the square root property. The square root of this fraction is the square root of the numerator divided by the square root of the denominator. Of course, we know that the square root of 4a squared is 2a. So that's where this 2a comes from. And then we subtract minus b over 2a, and now since they have a common denominator, we can combine this into one big expression like this. And that is the quadratic formula. And notice that we have a plus or minus here. That really represents two numbers here. Okay, so that's the quadratic formula. And some of you people that people like me, when we were students, we had to memorize this. You can, of course, I'm not going to make you memorize this. If you want to write it down, that's fine. However, the more you use it, the more it'll be in your stick in your mind, hopefully. Okay, so some people don't like it because they think it's an ugly expression, a complicated expression. Believe me, there are. If you're in math long enough, you see a lot uglier expressions than this. Okay, this isn't too bad. Now notice that this they have this quantity here, b squared minus 4ac. That is that tells us something, because if this number under the square root is negative, then this doesn't make any sense, right? This is undefined, and there would be no solution. And if you have b squared minus 4ac as a positive number, then this would be two solutions here. And then if b squared minus 4ac happens to be 0, then the square root of 0 is just 0, so we just get negative b over 2a, and we have one solution. So that's why b squared minus 4ac is kind of important. We can just look at this and determine how many solutions we have without really necessarily computing them. So we have two solutions if the discriminant is as positive, 1 real solution if it's negative, and 0 real solutions if it's negative. Hopefully I said this. So if the discriminant is positive, we have 2 real solutions. If it's 0, we have 1 real solution. And if it's negative, we have 0 real solutions. And as far as what this means to the corresponding graph, look here, we can see that, well, in this first case, we have 2, in this one case, these are all graphs of y equals ax squared plus bx plus c. And in this case, we have 2 real solutions, right? Because we have 2 x-intercepts, and therefore we would have, the discriminant would have to be positive. Here, this is a case where we have 1 x-intercept, so that's 1 real solution, and the discriminant has to be 0. And you'll see that in this case, the vertex is actually the x-intercept. And then this is a case where the parabola either opens up above the x-axis or below the x-axis, and there's no x-intercepts. So in this case, the discriminant would be negative in this case. All right. So just look at some examples here. Okay, so in this case, in the first example, we have an equation in the form x squared minus 10x plus 17. So the 1 here is kind of understood. So a is 1, b is negative 10, and c is 17. It's negative 10 because this is the same thing as plus negative 10. So, so negative b plus or minus the square root of b squared minus 4ac over 2a becomes negative 10 plus or minus the square root of negative 10 squared minus 4 times 1 times 17 all over 2 times 1. Okay. And now we just have to take our time simplifying. Negative 10 is positive 10. This is plus or minus 10. Negative 10 squared is 100 minus 4 times 1 times 17 all over 2 times 1, which is 2, this becomes 10 plus or minus the square root of 32 over 2, and this becomes 10 over 2 plus or minus. The square root of 32 can be written as, we can in fact pull off a 2. With 32 is, of course, 4 times 8, and the square root of 4 is 2, so it would be 2 square root of 8 over 2. And so what this becomes, this turns out to, 10 over 2 is 5, and these 2's cancel, and we get plus or minus square root of 8. So that's what x would be in these two. You get these 2 real solutions. Okay. How far should you go? I mean, I guess I would accept this, but the computer might not. All right, so simplify as much as you can. All right, so in this next case, we have case A is 4, B is 3, and C is negative 7. So once again, we'll use this expression, and we get minus B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. All right. So, what will that be? This is going to be negative 3 plus or minus the square root of 9 plus, because this minus and this minus cancel out, and we get 16 times 7, and of course, I don't expect you to do that in your head necessarily. This turns out to be, well, this turns out to be, well, the whole thing turns out to be the square root of 121. Just 16 times 7, 112, okay. Over 8. And then this is negative 3 plus or minus the square root of 121 over 8. And we're kind of in luck because 1 square root of 121 is 11. Okay, we won't always be able to simplify this far. So if we take the plus 1, we'll get negative 3 plus 11 divided by 8. Well, that's 8 over 8. That's 1. And negative 3 minus 11 over 8 is negative 14/8 or negative 7/4. So the two solutions would be 1 and negative 7/4. Okay, so in this case, when you have you're taking the square, when you have a perfect square, you should be able to simplify this like this. Now, for this next example, you might recognize this from the previous lesson, and we have x squared plus 12x equals 10. We did that by completing the square. Now we're going to do the same problem using the quadratic formula. So let's first take the 10 to the other side, because we need to read off what our a, b, and c, where everything is on one side and zero's on the other. So we get this, and so a is 1, b is 12, and c is negative 10. And therefore we use our quadratic formula again. We get minus b plus or minus the square root of b squared minus 4ac all over 2a. And this turns out to be, doesn't turn out, well, we'll see. Let's work through it. So this is going to be negative 12 plus or minus the square root of 144 plus 40 over 2. And then this would be negative 12 plus or minus the square root of 164 over 2. And see, the square root of 164 that is obviously not a perfect square, but we can actually write this as 2 times the square root of 41, because the square root of 4 times 41 is 164. So this becomes negative 6 plus or minus square root of 41, okay, which is, I think, what we got on the other sheet, on the other lesson. So that's what x will be in this case. All right. Let's take a break, and then we'll finish the rest of the examples in the next video.